The sum of the first n terms of an arithmetic sequence is given by Sn is equal to Pn squared minus Qn, where P and Q are positive constants. It's also given that S4, which is the sum of the first four terms, is equal to 40, and also that S5 is equal to 65. So the sum of the first five terms is 65. We're asked to find P and Q. Well, how can we do this? Well, what we can do is we can use this information here in order to give two equations and then solve for P and Q using substitution, elimination, or graphing, although I wouldn't recommend graphing, that's a pain. Okay, so what we're going to do here is, let's note that S of 4 is 40, so I'm going to plug in 40 for S of n, and then I'm going to plug in 4 for n, right? So S of n is equal to 40, which is equal to P of 4, sorry, this should say 4, P of 4 squared minus Q times 4. And then that means that 40 is equal to 16P minus 4Q. And then if we divide everything by 4, we get that 10 is equal to 4P minus Q. And that's our first equation. Now what about S of 5? The sum of the first five terms is 65, and that's also equal to P times 5 squared minus Q times 5. Therefore, 65 is equal to 25P minus 5Q. And then if we divide all of these by 5, 65 divided by 5 is 13. 25P divided by 5 is 5P. And 5Q divided by 5 is just Q. So therefore, we have these two equations. We now know that 10 is equal to 4P minus Q, and 13 is equal to 5P minus Q. So we can find P and Q just by using substitution or elimination. Either method is good. I'm going to go through elimination. So I'm going to line these up. 10 is equal to 4P minus Q, and then 13 is equal to 5P minus Q. And I'm going to subtract the second equation from the first one. 10 minus 13 is negative 3. 4P minus 5P is negative P, and Q minus negative Q is 0. So we're left with negative 3 is equal to negative P. That means P is equal to 3. Now if P is equal to 3, we can just plug that back into one of our original equations. 10 is equal to 4 times P, or 4 times 3, minus Q, meaning that 10 is equal to 12 minus Q, meaning that Q is equal to 2. Therefore, that's our answer, that P is 3 and Q is 2.